Welcome to Algebra 1, Lesson 25 with Ms. Barrett. This week, we will be going over the quadratic formula, which will wrap up our discussion of factoring quadratics. We are going to start this discussion by a review of the discriminant. So we so far have gone over multiple methods of solving quadratic equations. So we solve by factoring. Okay, we solve by factoring. We've talked about solving using the by graphing. Okay, and in factoring, we've done GCF factoring. We've done when A is equal to 1. Sorry, we've done when A is not equal to 1. We've also done grouping, and I think that's it. Okay. So when we're solving quadratics, okay, remember solving means that we're looking for the x-intercepts, right? We're trying to find the x-intercepts, or where the graph crosses the x-axis. When we're talking about solving, if we're looking at a graph, what that would look like is we would have three different solutions, different types of solutions. We could have generally a regular quadratic where it could look like this, and we have two solutions. Okay. Okay, the graph, the parabola touches the x-axis in two spots, okay? So it's two solutions. Okay, you have two solutions. You can also have one solution. And of course, the graph doesn't have to look like this, ladies and gentlemen. One solution, okay? And you can also have no solutions. And no solutions means that, or zero solutions, means that the graph does not touch the x-axis at all, okay? So the options are two solutions, one solution, no solution. Okay? Now, we can use the discriminant to determine what kind of solutions we have without having to actually solve the equation. So what this is saying is that we can know how many solutions there are without graphing it and without factoring it to solve it. Okay? We use the discriminant for that. B squared minus 4AC. And again, this is a review. So we've already gone over this, but this is just a review. So this is the discriminant. Okay, this is what we're deeming important here. All right, so the discriminant is a part of the quadratic formula. So the whole quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac. And notice this part that I have highlighted here is the discriminant, which is under a square root. So technically in the quadratic formula, this whole thing is being square rooted. And then you divide that by 2a. Okay, we divide that by 2a. So for example, here we have a quadratic equation, x squared minus 6x plus 9. So when you're given an equation like this, a quadratic equation like this, your first step is to identify your a, b, and c. So here my a is 1, my b is negative 6, and my c equals 9, right? I think we're all good on what's a, b, and c. Now I'm then going to plug in my a, b, and c into the discriminant, okay? So for this example, x squared minus 6x plus 9 equals 0, the discriminant would be b squared, which is negative 6 squared, okay, minus 4 times A, which is 1, times C, which is 9. And all I did was plugged in this A, B, and C. So plugged in -6, plugged in -1, and plugged in 9. That's all I did here. Okay, identify your A, B, and C, plug it into the discriminant. Now, -6 squared is 36. Minus 4 times 1 is -4. Times 9 is -36. Okay, and 36 minus 36 is 0. So the discriminant here for this equation, x squared minus 6x plus 9 equals 0, is 0. Okay. The discriminant for this quadratic equation is 0. And that's how you find a discriminant. Plug in what you know, simplify. Now, there are some rules for discriminants. If the discriminant is 0, just like we did here, if the discriminant is 0, will the quadratic factor? Yes, the quadratic will factor. Okay. And the solutions will be one real number. One real number. Okay. That's like this one up here. If I don't know what the equation for this graph is, but what I do know is that the discriminant for this one is 0 because there is a solution and it's just one solution. If the discriminant is a negative number, if the discriminant is a negative number, the quadratic will not factor. No. And there are two imaginary, what we call two imaginary solutions. Okay, two imaginary solutions. So if the discriminant is 0, the quadratic will factor and there's one solution. If the discriminant is a negative number, then the quadratic will not factor and there are two imaginary solutions. Now remember, the difference between a real number and an imaginary number is that a real number can be found on a number line. So it's any number that can be represented rationally, okay? So 0.333333, 2.4, 5, -5, -6, -0.00005558888, okay? So any number that can be represented as a whole number, as an integer, or a rational number, okay? If the discriminant is a positive, okay, a positive perfect square, then it will factor, yes. And there are two real solutions. Okay. Two real solutions, two real number solutions, right? And then lastly, if the answer or the discriminant is positive and it's not a perfect square, okay, it also will factor and it will also have two real solutions. Okay, so these are the options. you're either going to have a discriminant that's 0 with 1 real solution, a negative discriminant with 2 imaginary solutions, okay, or a positive perfect square discriminant with 2 real solutions, or a positive non-perfect square discriminant with 2 real solutions. So those are your options. All right, now, in summary, the discriminant is this. The discriminant is b squared minus 4 times a times c. Okay, we know that. If the discriminant is 0, there is 1 solution. If the discriminant is negative, there are 2 imaginary solutions. If the discriminant is positive, whether it's a perfect square discriminant or a non-perfect square discriminant, if it's a positive number, then there are 2 real solutions. Okay? There are 2 real solutions. Now let's look at 2 examples. Okay? And see how we can determine how many solutions a quadratic will have. So looking at the first one, it says use the discriminant to determine the number of and kind of solutions to these equations. Do not actually solve the equation. So we're just using the discriminant here. So first things first, we have x squared minus 6x plus 10 equals 0. First thing we're going to do is we're going to find our a, b, and c. Define it. A equals 1, b equals negative 6, c equals 10. Okay? Always define your a, b, and c. That way you know what you're plugging into your discriminant. Now we're going to have b squared minus 4 times a times c. I'm going to take my b and I'm going to plug it in. So it's going to be b squared is going to be negative 6 squared, okay, minus 4 times a, which is 1, times c, which is 10. Okay, all I did is plugged in what's in the green, if you can see it. Now, negative 6 squared is 36, minus 4 times, negative 4 times 1 is negative 4, times 10 is negative 40. Okay, so we have 36 minus 40, which is negative 4. That's the discriminant here. Now we say based off of this discriminant, negative 4, how many solutions will this x squared minus 6x plus 10 have? And we know that if the solution, the discriminant is negative, then it will have 2 imaginary solutions. Okay, 2 imaginary solutions. Okay, what kind? Oh, I'm sorry. 2 solutions. What kind is going to be imaginary? Okay, that means. Okay, that means when we graph it, originally we said it was no solutions, but really what that means is that the graph does not touch the x-axis. So we don't have any defined solutions, but we do have imaginary solutions, okay? So how many solutions? 2. What kind of solutions? Imaginary. Now let's do number 2. I have a equals 1, b equals negative 6, and c equals negative 8. I'm going to plug in what I know into b squared minus 4 times a times c. And that's going to give me negative 6 squared minus 4 times 1 times negative 8. Now you have to be careful with your multiplication here because your signs will change. So negative 6 squared is 36. Negative 4 times 1 is negative 4. Times negative 8 is positive 32. Okay, Negative 4 times 1 is negative 4 times negative 8 is positive 32. 36 plus 32 is 68. So our discriminant is 68. Our discriminant is 68. So 68 is positive. So that means how many solutions will I have? I will have 2 solutions. And what type of solutions will I have? I will have 2 real solutions, which means that the graph looks like this. It crosses the x-axis twice. Okay. Okay. All right. So I wanted to make a correction on the first page. It's not going to say no solutions. I'm going to change that now. It's going to be 2 imaginary solutions. Okay, 2 imaginary solutions. So for your practice, I'm just going to give you 2 problems. And I ask you, use the discriminant to determine the number of solutions. So you're going to take each of those problems, follow the steps that we just did in the notes, and you're going to tell me how many solutions and what type of solutions each of these 2 problems have. Hope everyone has a great day. Bye.